So here they want us to calculate the density of a gas in grams per liter. So already I know that eventually those are the units I'm going to want. And it says it's 733 millimeters of mercury. What is that unit a measure of? Pressure. Good, right, because when we talked about, so other than atmospheres, that's the only pressure unit I might expect you to work with. Because when we talked about measuring pressure using a barometer, if you recall, we said you take a tube of mercury, you put an empty pan on top of it, and then you flip it over, and as the mercury starts to fall out, it creates a vacuum at the top of the tube. So gravity is pulling the mercury down, but then the atmospheric pressure is hitting back down on the surface of the mercury, pushing it back up the tube. So the pressure is measured by how high the mercury is pushed up the tube, which is why we have units of millimeters of mercury. So there is a relationship, 760 millimeters of mercury equals 1 atmosphere. But in this case, it's only 733 millimeters of mercury. And the temperature is 46 Kelvin, or 46 Celsius. So if I want density, I need grams per liter. So I might say, well, I don't really have grams given to me, and I also don't have liters given to me. I've got information I can use to get pressure and temperature. So if I'm thinking about PV equals nRT, I always know R. In this case, I've got temperature, I've got pressure, but I don't have volume and I don't have moles. So I can't really solve the formula for one variable if there are two unknown variables. So what do I need to do here? Well, what I'm looking for in the end is a ratio of grams divided by liters, or the amount divided by the volume. So instead of using the ideal gas law to solve just for volume or just for moles, I can use it to solve for the ratio, which will be an amount per volume. And so what I want to do is to get grams per liter. I know there's a relationship between moles and grams. So if I could get moles per liter, I could convert that into grams per liter. So that's what the ideal gas law will allow me to do. Instead of solving for moles or for liters, I want to rearrange it to solve for moles per liter. So if I divide both sides by volume, and then divide both sides by RT, on this side I'll have moles divided by liters. So P over RT equals moles over liters. So if I want to get N over V, I need to plug in the pressure, but it's got to be in atmospheres. So the 733 millimeters of mercury has to be converted to atmospheres, which the relationship is 760 millimeters of mercury equals 1 atmosphere. So 733 divided by 760 gives me 0.964 atmospheres. So that's what I'll plug in. So I've got pressure over RT. That's what I'll plug in for the pressure. I want to divide that by R, 0.08, 206 liter atmospheres per mole Kelvin. And I need to divide by the temperature, but it's got to be in Kelvin. So again, 273.15 to get to Kelvin. It's going to give me 319 Kelvin. So I can see the Kelvin's canceling, the atmosphere's canceling, and I have moles per liter, which is good because I'm eventually looking for grams per liter, and I'm one step away. All I have to do is convert the moles into grams. So when I get that number, it'll be 0.964 divided by 0.08206 divided by 319. I get 0.03. So I have 3 sig figs, but I want to keep one extra one, so I only want to round at the end. And I've got moles per liter. So now I'll plug that in here. Moles per liter. I've already got the unit on the bottom that I want. I just have to convert the moles on top into grams. How do I do that? I need the molar mass, which is either got to be given to me or I need to know what the substance is. So the substance is HBr. So I had the mass of 1 hydrogen, which is 1.008, plus the mass of 1 bromine, 79.904, and I get 80.91 grams per mole. So that's the number of grams equal to 1 mole. So now my moles will cancel, and I'll have my answer. And I'm limited to 3 sig figs. Oops, I think I 0.3683 times 80.91. So I've got 2.98 grams per liter.